Okay, so the last video is going to be a combination of the law of detachment and the law of syllogism. So they're going to be combined, which means you're going to see three statements. You're going to see two conditionals, because that's what you have to make or to write a conclusion for the law of syllogism. And then there's going to be a third statement, which is going to be able to connect to one of the conditionals to use the law of detachment. Okay? And sometimes there's more than one conclusion that we can draw from the law of detachment, but we can kind of combine them into one statement. So let's give an example here. So it says, if a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. So you can see that the conclusion of one is the hypothesis of the second statement. So I can draw one conclusion using the law of syllogism. If a river is more than 4,000 miles long, then it is the longest river in the world. So you can see that that is using the law of syllogism. But there's a third statement, and that statement says the Nile is 4,132 miles long. Well, that statement matches the hypothesis of the first conditional, if a river is more than 4,000 miles long. So the conclusion that we can draw is, if the Nile is 4,132 miles long, that is more than 4,000 miles. If it's more than 4,000 miles long, then it's longer than the Amazon. However, we already said if it's longer than the Amazon, then it's the longest river in the world. So we can immediately kind of use this statement and plug it into the law of syllogism. This matches the hypothesis if a river is more than 4,000 miles long. What does it say happens if a river is more than 4,000 miles long? Well, it says that it is the longest river in the world. So we can immediately use a specific example here and say that the Nile is the longest river in the world. So we can use the law of syllogism and the law of detachment together to form some conclusions. All right, let's look at the next one. The Volga River is in Europe. There's our statement, but let's look at our two conditionals. They are out of order. We're going to have to reorder them. If a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. If a river is in Europe, then it is less than 2,300 miles long. So you can probably see that this should be first and this should be second, so that the conclusion of this one matches the hypothesis of the second. So if that's the case, then the first law of syllogism conclusion I can draw is, if a river is in Europe, then it is not one of the world's 10 longest rivers. Okay? All right, so then what does this statement tell us? The Volga River is in Europe. If I'm looking at that specifically, okay, that matches this hypothesis. So if a river is in Europe, then it is less than 2,300 miles long. Okay, well, we already said the Volga River is in Europe, so therefore the Volga River is less than 2,300 miles long. But we made another statement from that when we combined the law of syllogism. We said that if a river is in Europe, it is less than 2,300 miles long, but then we said if a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. So if I take this statement here and plug it in here, then I can lead to a further conclusion, and that further conclusion is actually right over here in my law of syllogism. If a river is in Europe, Volga River is in Europe, then it is not one of the world's 10 longest rivers. So there is my conclusion. If, whoops, not if, the Volga River is not one of the world's 10 longest rivers. So I'm using the law of syllogism, and then I'm drawing another conclusion. That's only going to happen if that conclusion matches the hypothesis of the first conditional we used in our law of syllogism. Okay, let's do another one that has to reorder. If games are canceled, then Maria reads a book. If it snows, then games are canceled. You probably could see that the conclusion here matches the hypothesis here, so they should be switched. If it snows, then games are canceled. If games are canceled, then Maria reads a book. So I can connect the hypothesis of this one with the conclusion of this one. If it snows, then Maria reads a book. Okay, now look at the statement here. This statement here matches with this. It is snowing. What does it say happens if it is snowing? Well, if it is snowing, then the games are canceled. Okay, so we're going to be able to write that. The games are canceled. Now, I could have said, okay, well, if it's snowing, the games are canceled. If the games are canceled, then Maria reads a book, but I already have that. If it snows, then Maria reads a book. Well, I've already gotten that, so I'm just simply going to mention the conclusion that is drawn from the fact that it's snowing. If it's snowing, the games must be canceled. Okay, look at the next one. If two angles are formed by perpendicular lines, then the angles are both equal to 90. If the angles are equal to 90, then they are right angles. So your first conclusion is your law of syllogism. If two angles are perpendicular, that's the perpendicular sign, perpendicular lines, then they are right angles. Okay, conclusion of one match the hypothesis of the second. Okay, now look at the next statement. Angle A and angle B are 90 degrees. That doesn't match with this. That matches with the hypothesis of the second statement. So I'm just going to draw one conclusion, because if I know that if angles are 90, they're right angles, and angle A and angle B are 90, then I know that angle A and angle B are right angles. That's what it says. If the angles are 90, then they're right angles. Angle A and angle B are 90, therefore they must be right angles. All right, and then the last one. If AM, segment AM, is equal to segment MB, then M is the midpoint of AB. If M is the midpoint of AB, then AM plus MB equals AB. Okay, so you can see the conclusion of this one matches the hypothesis of this one, so I'm going to be able to combine them. If AM equals MB, then draw the conclusion here. AM plus MB equals AB. Now look at the second statement. It's got a specific number. Segment AM and segment MB are both 6. So that matches with this. If AM and MB are both 6 and the midpoint is that M is the midpoint. But what does the fact that M is the midpoint mean? Well, we already wrote over here, if AM equals MB, then AM plus MB equals AB. So I'm going to take this statement and plug it in here, but then it's going to lead me to the second statement anyway, so I might as well just plug it into the syllogism. If AM equals MB, then what? AM and MB are both 6, which means they're both equal, right? That makes sense. It says they are both the same amount. That means they're equal. Then this statement is true. AM plus MB equals AB. Okay, but let's be more specific because they gave us a specific number. That means that 6 plus 6 is 12, right? I know that if both of them are 6, 6 and 6, and they add together, that is going to make the length of segment AB is going to be 12. So you can kind of be more specific if more specific information is being given to you. All right, so hopefully that helps you understand combining the laws of deductive reasoning.